Hello everyone. In this video, we are going to discuss about Coulomb's law. We will be discussing about the statement of Coulomb's law, then definition of 1 Coulomb of charge, and after that we will be discussing about Coulomb's law in vector form. So first of all, let us see the statement of Coulomb's law. It states that the force between 2 point charges, we know that when we consider two charges, definitely there will be a force between them. That force can be the force of attraction or force of repulsion. We know that like charges repel each other, unlike charges attract each other. So Coulomb's law states that the force between 2 point charges, that is directly proportional to the product of the magnitude of the two charges and inversely proportional to the square of the distance between the charges along the line joining the two charges. So let us discuss the mathematical expression of Coulomb's law. You see, here I have considered two charges. One is Q1, another one is Q2. They are separated in vacuum by a distance small letter r. Then, we know that force is a vector quantity. We usually represent it like by vector F. Then the magnitude of the force means F. Okay, then this Coulomb's law states that this force, that is definitely there is an electrostatic force of repulsion or attraction between Q1 and 2. Whatever be that force, whether it is the repulsive force or attractive force, the magnitude of that force F, it is directly proportional to the square, it is directly proportional to the product of the two charges. Product of the two charges means Q1 into Q2. And you see it is inversely proportional to the square of the distance between the charges. That is F is proportional to 1 by R square. So when we combine these two equations, we can write F is proportional to Q1 Q2 divided by R square. Then, when we replace this proportionality sign with an equal sign, we will be writing one proportionality constant there. That proportionality constant is taken as K. So, K into Q1, Q2 divided by R square. See, this K is a constant. This K has a constant value. This is actually equal to 1 by 4 pi epsilon 0. Okay, this is equal to 9 into 10 raised to 9 with unit. See, this epsilon 0, 4 and pi, they have usual meanings. Epsilon 0, this is actually known as permittivity of free space. Okay, epsilon 0, this is actually the permittivity of free space or vacuum. Okay, it has a value which is equal to 8.854 into 10 raised to minus 12 Coulomb square, Newton raised to minus 1, meter raised to minus 2. So you see, we have this expression F is equal to K into Q1 Q2 divided by R square, where K is equal to 1 by 4 pi epsilon 0. So you can write this expression as F is equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by R square. Okay, now suppose that this Q1 is equal to 1 Coulomb. Okay, Coulomb, that is the SI unit of charge. And let Q2 be 1 Coulomb. Okay, now suppose that the distance or separation between these two charges Q1 and Q2, that is small letter r, this is equal to 1 meter. Okay, then what will be the force between, the magnitude of the force between these two charges Q1 and Q2? We can apply this equation or we can make use of this equation now. So, by using this equation, we can write F is equal to, okay, K into or 1 by 4 pi epsilon 0 into Q1 into Q2. Q1 is 1 Coulomb, Q2 is 1 Coulomb divided by R square. See here we have taken R as 1 meter. So, 1 square. Okay, so this is equal to what? 1 into 1 into 1 into 1 into K is actually K. Okay, 1 square is 1. So, this is equal to K. What is the value of K? K is 9 into 10 raised to 9. See, this is the force now. So, SI unit is Newton. Okay, that is when these two charges are having the magnitudes 1 Coulomb and they are separated by a distance of 1 meter, then the force between these two charges will have a magnitude which is equal to 9 into 10 raised to 9 Newton. So, by using this example, we can actually define 1 coulomb of charge. You see, 1 coulomb, that is the charge that when placed at a distance of 1 meter from another charge of the same magnitude 1 coulomb in vacuum experiences an electrical force of repulsion of magnitude 9 into 10 raised to 9 Newton. Okay, if we are considering the two charges as positive charges, then electrostatic repulsion between them. But if one is having, a negative charge, another one is having a positive charge, then electrostatic force of attraction between them. Okay, so here we can define 1 coulomb of charge as it is the charge that when placed at a distance of 1 meter from another charge of the same magnitude 1 coulomb in vacuum that experiences an electrical force of magnitude 9 into 10 raised to 9 Newton. Now, let us discuss about Coulomb's law in vector form. Because you see, Coulomb's law gives us an idea about the force between the 2 point charges Q1 and Q2. We know that force is a vector quantity, so it will be having some vector form now. So let us discuss about Coulomb's law in vector form. So here, I have considered the same 2 point charges Q1 and Q2. Okay, let O be some origin. Then you see, the position vector of Q1, that is taken as vector R1. Position vector of Q2, that is vector R2. Okay, now I am taking the vector which is directed from Q1 to Q2. I am taking this vector as vector R21. That is vector R21 is the vector which is directed from 1 to 2. Okay, it is the vector leading from 1 to 2 or vector to 2, that is Q2 from Q1. Okay, vector R21 is the vector leading to Q2 from Q1. Okay. Now suppose we are considering the same charge configuration here. And if I am considering a vector to Q1 from Q2, that is here I am considering a vector leading from Q2 to Q1. Okay, it is a vector leading to Q1 from Q2. I am taking it as vector R12. So I hope you got an idea about the difference between vector R21 and vector R12. You see, vector R21, this is the vector leading to Q2 from Q1, and this vector R12, it is the vector leading to Q1 from Q2. Okay, now you see, you just consider this figure. I am taking this as figure 1 and I am taking this as figure 2. Now let us consider this figure 1. Here, by applying triangle law of extradition, we can write what? Vector R1 plus vector R21 is equal to vector R2. So, I am writing vector R1 plus vector R21 is equal to vector R2. Okay, from this we can write vector R21 is equal to vector R2. I am taking this vector R1 to this side. This becomes minus vector R1 here. Alright, now when we consider this figure, the second figure, here by applying the triangle of extradition, we can write vector R2, this vector R2 plus vector R12 is equal to vector R1. I hope you remember about the triangle of extradition that we have already discussed in our 11th standard classes. Okay, so here from this we can write vector R12 as vector R1, and I am taking this vector R2 from this side to this side. This becomes minus vector R2. Okay, so here we have vector R21 as vector R2 minus vector R1. Here we have vector R12 as vector R1 minus vector R2. Okay, now you see I am considering this expression. Okay, and I am taking a negative sign outside. So this becomes what? Vector R21 is equal to minus of, when we take this minus sign outside, this becomes vector R1 minus vector R2. See, what is this vector R1 minus vector R2? This is actually vector R12 now. So we can write vector R21 is equal to minus vector R12. Okay, or you can, that is vector R21 is equal to minus vector R12, or you can write vector R12 is equal to minus vector R21. Now you see this vector R21, it is a vector leading to Q2 from Q1. See, this vector will have a magnitude as well as a direction. So I am writing its magnitude as R21. Okay, magnitude of vector r21, which is r21. Then we have to write one unit vector here. Right. Then only it becomes a vector. So I'm taking that unit vector as r21 cap. Okay, r21 cap is the unit vector which is directed from q1 to q2. That is, I'm considering this unit vector. That is the unit vector which gives us the direction. Okay, from q1 to q2 as r21 cap. Similarly, here we have vector r12. This also will have a magnitude. I am taking it as r12, and the unit vector which specifies the direction from q2 to q1 as r12 cap. Okay, so r12 cap is the unit vector. R21 cap, it is a unit vector directed like this from q1 to q2. R12 cap, it is the unit vector directed like this. Okay, that is from q2 to q1. So it is very clear from this figure that you see this R21 cap, it is actually equal in magnitude of R12 cap but opposite in direction. Okay, because both are unit vectors, both are having the same magnitude. Okay, both are actually the vectors between q1 and q2. Okay, and you see they are in opposite directions. So we put a negative sign here so that we can write R21 cap is equal to minus R12 cap. So you see this vector R21, it is the vector leading to q2 from q1, and this vector has a magnitude R21 and the unit vector which is giving the direction from q1 to q2, that is R21 cap. Okay. And you see vector r12, it is the vector leading to q1 from q2. This vector r12 has a magnitude r12 and the direction of this vector is denoted by this unit vector which is r12 cap. Okay, r12 cap is the unit vector here. So you see, we know that the direction of a vector is specified by a unit vector. If in general we can write that unit vector r cap as vector r divided by modulus of vector r. Okay, or we can write it as vector r by modulus of vector r means r itself. Okay, so here we can write this r12 cap as what? Vector r12 divided by r12. Similarly, we can write r21 cap as vector r21 divided by r21. And you see these two unit vectors r21 cap and r12 cap, they are equal in magnitude but opposite in direction. That is why we put a negative sign here. Now you see, we know that there is a force between these two charges. Suppose these two charges q1 and q2 are positive charges, so there will be a force of repulsion between them. So you see, we know that the force on q2 due to q1, that will be having a direction like this, no? Because q1 will try to move this q2 away from q1. So the force will be directed along this direction. I am taking this force on charge q2 from q1 or due to q1. I am taking it as vector F21. Similarly, we know that there is a force on q1 due to q2. Okay, that is q2 will try to move this charge q1 away from it. So the force on q1 due to q2 will direct in this direction. So I am taking this force as vector F12, where vector F12 is the force on q1 due to q2. Now you see, from Coulomb's law, we have the general expression for the force between these two charges as F is equal to 1 by 4 pi epsilon 0 q1 q2 divided by r square. This is the magnitude of the force which is acting between the two charges q1 and q2 separated by a small distance or separated by a distance small letter r. Now here, when we talk about the force on q2 due to q1, you see the force on q2 due to q1 which is vector F21. So I am writing vector F21. This force will have a magnitude and a direction. What will be the magnitude of that force? Magnitude of force acting on q2 due to q1 will be what? 1 by 4 pi epsilon 0 q1 q2 divided by square of the distance. So you see the distance between q2 and q1, the distance or the displacement which is directed from q1 to q2, that is r21. So I am taking r21 square Okay, then the direction of that force is along this direction, which is along this vector r21. So the unit vector which is directed along this direction is r21 cap. So we can write here r21 cap. Okay, so you see vector F21, it is the force on charge Q2 due to Q1 that has a magnitude 1 by 4 pi epsilon 0 Q1 Q2 divided by R21 square, and this force is a vector quantity. So we are writing one unit vector here which is R21 cap. Okay, similarly the force on Q1. Okay, the force on Q1 due to Q2 that is acting along this direction. Alright, so that force vector F12. Okay, see, I'm just considering this figure. So you see, when we consider this figure, the force on Q1 due to Q2, it is actually acting along this direction. That is, this is vector F12. So we can write that vector F12 as what? This also has some magnitude 1 by 4 pi epsilon 0 Q1 Q2 divided by, you see the distance to Q1 from Q2 which is R12. So R12 square, and the unit vector along this direction of vector F12 is R12 cap. So here R12 cap. Okay, so this is the magnitude of this force vector F12, and R21 cap is the unit vector which is directed along the direction of this force vector F12. And you see these two equations, no, this one and this one, these two are equally valid for any sign of Q1 and Q2. That is, Q1 and Q2 both can be positive, both can be negative, one can be positive, the other one as negative. These two equations are valid for any sign of Q1 and Q2. Now you see, if Q1 and Q2 are of the same sign, that is both positive or both negative, then you see there will be a force of repulsion between them. That is, Q1 will try to move this Q2 away from Q1. So the force on Q2 due to Q1 will be along this direction. Similarly, Q2 will try to move this charge Q1 away from Q2. So the force on Q1 due to Q2 that will have this direction. Okay. Now suppose Q1 and Q2 are of opposite signs. That is, one is positive, another one is negative. Then what happens? There will be a force of attraction between them. That is, Q1 will try to attract this Q2 towards it, and Q2 will try to attract this Q1 towards Q2. Right. So, what about the directions of the two forces acting between them? First, I am taking the force on Q2 due to Q1. Force on Q2 due to Q1 is what? Which is actually represented like this, no? Vector F21, which is a force on Q2 due to Q1. What will be its direction? You see, force on Q2 due to Q1 is actually Q1 will try to pull this Q2 or attract this Q2 towards Q1. Okay, so the force on Q2 due to Q1, which is vector F21, will have this direction. Similarly, the force on Q1 due to Q2, it is actually vector F12. What about its direction? You see, force on Q1 due to Q2. So, Q2 will try to attract this Q1 along this direction. So, vector F12 will have this direction. And you see, force on Q2 due to Q1 is vector F21. Force on Q1 due to Q2 is vector F12. And you see, we already got these two expressions for vector F21 and vector F12. Okay, and we have already got this expression R21 cap is actually minus R12 cap because they are the unit vectors opposite in direction, equal in magnitude. Similarly, vector R21 and minus vector R12, they are also in opposite directions. Okay, so they are having equal magnitude but opposite direction. That is why one negative sign is here. Now, I am considering this expression of vector F12. See, vector F12 is 1 by 4 pi epsilon 0 Q1 Q2 divided by R12 square into R12 cap. Okay, I am writing it as 1 by 4 pi epsilon 0 Q1 Q2 divided by, you see, this R21 and R12, they are equal in magnitude. So, I am just replacing this R12 square with R21 square. Okay, and you see this R12 cap. The negative of R12 cap is R21 cap. Or we can write minus R21 cap is equal to R12 cap. Okay, you can just multiply this equation with the negative sign in both the sides. So that becomes like this. So what I'm going to do is I'm going to replace this R12 cap with minus R21 cap. Okay, so minus R21 cap. Alright, so we can write it as what? I'm writing this negative sign first. So minus 1 by 4 pi epsilon 0 q1 q2 divided by, okay, R21 square into R21 cap. Now you see, this is actually vector F12. So vector F12 is equal to minus, what is this 1 by 4 pi epsilon 0 q1 q2 by R21 square into R21 cap? That is actually vector F21 now. So I am replacing this with vector F21. Okay, so you see we are getting the force on Q1 due to Q2 is equal to minus of force on Q2 due to Q1. That is the force on Q1 due to Q2 and force on Q2 due to Q1. They are equal in magnitude, and this negative sign shows that they are opposite in directions. Okay, so from this expression we can see that Coulomb's law agrees with the Newton's third law, because Newton's third law states that for every action there is an equal and opposite reaction. So you see there is a force on Q1 due to Q2 and in opposite direction but equal in magnitude there is a force on Q2 due to Q1. So we can say that Coulomb's law agrees with the Newton's third law. So you see, in this video we have discussed about the statement of Coulomb's law, its mathematical expression and Coulomb's law in vector form. I hope it is clear to you. Thank you.